viewers. Today we are going to see about feedback connection types. So we have four types of feedback connection. One is voltage series feedback, voltage shunt feedback, then current series feedback and current shunt feedback. These are the four basic feedback connection types. First we will see about voltage shunt feedback. So this is the amplifier and this is the feedback network beta, and this is the load RL, and here we represent the input as current source. Even if you have voltage source, that can be converted into current source. Why? Because if you have a shunted input, parallel input, then you must make use of current source. If it is going to be series, then we can go for voltage source. That's the idea. So now this is our basic amplifier A, and this is feedback network. So voltage shunt feedback. Voltage means you are taking the output parallelly and then you are giving that into, that means you are sensing the voltage. The voltage across the load is given to the beta network. The output of the beta network is given or shunted parallelly to the amplifier and to the signal source. So if this is the current source Is, the current going into the amplifier is In, and the current going into the feedback network is If. So the gain of this amplifier is output by input. Output is Vout and the input to the amplifier is In. So A is equal to Vout by In. So the unit will be in ohms. Whereas here the output is If. Whereas the input, since this is, if this is Vout, the same voltage will appear here and the same voltage comes as the input to the beta network. So the general formula is output by input. Output is If, input to the system is V0, that is beta. Here it is more. So if you multiply A and beta, the units gets cancelled and you won't get any unit at all. So this type of connection is called voltage shunt feedback. Next we will move on to current shunt feedback. So in current shunt feedback, we have to change this. So this is current and it is shunted. So input portion is not altered because we are sensing the current here, but the input is shunted across the amplifier. Okay. Now this portion will get changed. The beta value will get changed. A also will get changed. Now input side everything is same. Output I out is equal to IL. IL is the load current, the current that is going through the load, that is I naught. So the same current IL or I naught will come into the beta network, that is feedback network. So here the input is I naught, output is IF. So this will become IF. IF is the output and I naught is the input. Whereas for the amplifier, the output is I naught or IL and input is In. Input to the amplifier is In. The Is is the source current. So Is is equal to In plus If. So this type of connection is called current shunt feedback. This is second case. So this is called as current shunt feedback. This is current. First you have to represent the output, that is current. That current after the beta network is shunted or connected in parallel to the input of the amplifier. So that's why it is called current shunt feedback. Here it is current gain, no unit. Here is also, here the beta network is also current gain, so there is no unit. So this connection is called current shunt feedback. Okay. The third type is voltage series feedback. The next type is voltage series feedback. So the connection is voltage series feedback. So this is RL, the output is V out, voltage, series feedback. So the output of the beta network is given in series. So in that case you must use a voltage source, Vs. If it is shunted parallelly you must use current source. This is voltage source, so Vs. The voltage here is the feedback voltage Vf. Here also it is plus minus Vf, and here it is Vin, plus minus Vin. So now output by input, output is V out, so V out by V in, voltage gain. And for the beta network, the output is Vf and the input is V naught, because we are tapping the voltage across RL, which is V naught. So V naught is the input. So beta will be Vf by V naught. So the output of beta is V out, input is V naught. This is voltage gain, this is voltage gain, no unit. So when you multiply A and beta, there is no unit. So this connection is called voltage series feedback. Voltage series feedback. So the first term refers to the output voltage and the second term series refers to the input, how we are feeding into the system. So this is voltage series feedback. Next we are going to current series feedback. Current series. So this part will get changed. Input is not changed. Current series feedback. So first term refers to the output. So here it is current series feedback. Current series feedback. Here we are going to represent as current I naught, which is equal to IL. IL is the load current. The same load current or the I naught output current will enter into the beta network. The output of beta network is Vf. So output is Vf, input to the system is I naught. So Vf, V voltage by current will give you the unit as ohms. Here the output of the amplifier is I out and the input is V in. Here the unit is mho, I by V. So when you multiply A and B, here current divided by voltage, here voltage divided by current. So the unit will be, no, there won't be any units. So this is current series feedback. Okay. So the important point here is, if you feed input to the system is in series, then you must make use of voltage source. If it is parallel, then you have to use current source. So these four types of feedback connections you must know, and how to represent the input side, whether it's a current source or voltage source, that based on the block diagram. So any circuit which is having a feedback can be modeled in one of these four connections. Each connection has its own advantages. So those things in detail we will be covering in individual circuit analysis. Hope you have understood the basic four types of feedback connection. Thanks for watching this video. Nandri.